What's up, students? It's week 9. Where has the time gone? This is my last video lectures. This is the last time you have to listen to me blathering on YouTube. And in this video, I'm going to share my 5 tips for effective data visualizations. So let's go ahead and get started. The first principle of good data visualization is that a graph is not just an impartial collection of facts. It should make an argument. So your data isn't going to speak for itself, right? You have to arrange the visual information on the page in a way to make your case completely clear, right? And I have a really good example that I used to illustrate this point. And so let me go and pull this up here. So this is a study that was done in 2013 by the Pew Research Center. And the graph here says more than half of online adults watch comedy, humor, and how-to videos online, right? So they were looking at how people are consuming online video content, right? And you can see comedy humor in 2007, about 31% of the public was viewing those kinds of videos. Then it went up slightly in 2009, and then by 2013, almost 58% of the public were viewing that kind of content, right? Similar kind of thing with music, right? So 22%, only about a quarter of the public was consuming it in 2007, and by 2013, almost 50% of the public was consuming, right? And so this graph makes a real boring, but nevertheless important point, right? It's showing that increasingly the public is consuming more of their information in online spaces, right? But that isn't what the media picked up. That's not the thing the media chose to emphasize about the data. Instead, they were really focused on this little thing here at the bottom, right? And so you can see there's this place at the bottom. This is adult movies, right? And of course, you know what adult movies are, I hope, right? Adult movies are pornography, right? That's what we're talking about, right? And you can see the same trend is going on here, right? So 6% of the public consumed pornography in 2007, and now that has gone up to 12% of the public, right? But there's a problem, right? And the problem, hopefully this problem is clear, is that there are way more people viewing adult content online than is shown by these numbers, right? Obviously, some people are lying in this particular survey, right? I mean, you really have to think about this. And what they're saying here is that more people are watching how-to videos on the internet than people that are consuming content on like Pornhub or something like that, right? And we know based on internet traffic numbers that that's absolutely impossible, right? So that's kind of funny that there's all these people reluctant to admit this kind of thing on the survey, and of course that is what the media picked up on, right? And so you can see all these different articles. One of them from this week says why Americans still can't admit to watching porn, right? There's another one here that says hardly anyone admits to watching online porn, and then there's my favorite, which is this one in the lower right hand corner over here, right? And this one says 12% of Americans admit to watching porn online. The other 88% must not have the internet, which is a real funny clickbaity kind of title. But the thing that really gets me about this particular article is there's this guy like sitting out at a cafe or something like that, and he's smiling at the camera and looking at his computer. They've decided to attach this guy to this article. And I don't know what this guy's doing, but I have to think that the reason they're showing this picture is because he's watching internet porn in this particular cafe. So very strange gentleman. Don't do that in public. That's probably a bad call, right? So anyways, the point here is that the data that you collect can tell a lot of different stories, right? In this case, there's two very clear stories that could be articulated with the data, right? And so you have to decide what argument you want to make, and then you have to shape your data in such a way to make that point clear, right? All right, second point is that figures don't speak for themselves. They always should be accompanied by text, right? And so don't assume that people are going to get it just by looking at your figure, right? You need to have some text along with it to make your point completely obvious, right? So here's an example of a piece of data that isn't entirely clear at first glance. This is actually from a white paper that was produced right here in the university, right? And it's basically looking at the amount of plastic waste from different rivers around the globe, right? And then as you can see, as the circle gets larger, right, you can see the amount of plastic waste increases, right? And so the graph is telling a story, right? So if you look at the graph itself, hopefully you can see the point it's making is quite clear, right? And then a lot of the plastic waste seems to be pouring into the ocean is coming from rivers in Eastern Asia, right? So especially along the Chinese coast, in Indonesia, and those sorts of places, right? So that's the argument the graph is making here, right? And so they do include some text to emphasize the points they're trying to make, right? And so they say, research to date suggests that the majority of this plastic pollution comes from only a handful of rivers worldwide, though more research is needed to clarify these estimates. What is clear is that for many reasons, volume of plastic emissions is not equitably distributed across the globe, with some regions, and in some cases individual rivers, identified as particularly high plastic emitters, right? And so if you go to back to the figure, you can see that point really clearly emphasized in the graph itself, right? So remember, you gotta put some text along with the graph to help readers figure out how to interpret the data, right? All right, third thing, this is KISS, keep it simple, stupid. And this is the same thing, hopefully you've learned about writing this entire quarter, right? The simpler and more concise that you can make your graphs, typically the more effective they are, right? And this, one way to frame this is through a debate between two famous data visualization experts. One of them is the guy on the right. His name is Nigel Holmes. And I love this picture of this guy. He's like the coolest older human in the world. I love those little blue glasses and how they match the shirt. I think that's the coolest thing ever. But anyway, so he's a journalist and a visualization expert. And then the other one is Edward Tufte, who actually is an engineer, right? And so these people had an argument in the 80s, and I think the results of how that went will emphasize this point a little more clearly, right? So Nigel Holmes was really famous for producing these very clever kind of graphs, right? So here's an example here, right? This is one that Edward Tufte really took issue with, right? And the graph says, diamonds were a girl's best friend. Average price of a 1 carat D flawless, right? And then you can see this incredibly sexist image of this woman here with these gigantic lips, right? And then you can see, I don't know, he's trying to be clever where he's got the graph paper on her legs for her fishnet stockings. So I guess that's clever or something. And anyway, and then you can see the numbers here being emphasized on the curvature of her butt and going down to the tip of her toes, right? So if you start on the very, I don't know, the bottom of her buttocks in 1978, you can see that the diamond purchases were around like $20,000. And then there was the spike in 19 up to $60,000. And then it sort of dropped off again after that, right? Now, the point Tufte's making is that this trend is remarkably unclear from this graph. It takes a few minutes to sort of figure out what it's trying to say, if you see it at all, right? And so Tufte was talking about how, while some of these clever graphs may be aesthetically pleasing, definitely not this one because it's a sexist image, but other ones Holmes made, right? That it was not achieving its main purpose, which is to display the results in a clear and concise way, right? And so since then, the dominant paradigm, especially in the sciences, has moved towards functional simplicity, right? And you can see a real good example of what functional simplicity is in this graph here. This I took from a study on gun control measures, right? And it's looking at the results of a gun control law that was passed in the mid-90s that instituted some restrictions on what people can purchase and how they can purchase them, right? And you can see they're comparing the solid black here is Connecticut, right? So that's the actual homicide rates in Connecticut, right? And then they created a synthetic Connecticut by cobbling together a bunch of nearby states that didn't institute those measures, right? And the point here is you can see really clearly the argument the graph's trying to make. There's a divergence right here in the mid-90s, shortly after the law was put into place. And the synthetic Connecticut, their gun rates went upwards, right? While the control Connecticut went, or the normal Connecticut, they went downwards. Right? And so there was obviously the argument here is that law had some sort of effect. Now this graph here is really boring and very visually unappealing, and that's partially perhaps because of the limitations of the journal. They might have required people to produce black and white graphs, but this doesn't always have to be the case, right? You don't have to forget your aesthetic principles when you're putting together pleasant data visualizations. And a real good example of that is the famous hockey stick graph that was put together by Michael Mann. I follow him on Twitter, right? And anyways, this is looking at climate change and temperature increase over time, right? And I think this graph is gorgeous. I think it's a beautiful, well-constructed graph. And there's a lot of reasons for that. Part of it is the color scheme that's used here, right? The blues and the reds are really aesthetically pleasing. Another part of it is the way they express the possible error in the graph is that sort of light gray, this sort of is lurking in the background here, right? And so there are a lot of things that are really aesthetically pleasing about this graph, even though it follows those principles of aesthetic simplicity that we talked about earlier, right? So just because it's a simple graph doesn't mean it can't be aesthetically pleasing. That's the point, right? Fourth thing is, if you're going to use tables, just make it clear that tables are best used in situations when you want to draw attention to the raw data. So they have a real limited purpose, right? So if you really want the reader to focus on raw data, a table is often a good tool to use, right? So here's an example of an effective table. And part of the reason I kept this in here is because I thought it was really cool, because I showed this in my technical communication class last quarter, just as the coronavirus thing was sort of taking off. And I think it's kind of interesting to compare what was going on there to what's going on now, right? But anyways, you can see here, they're looking at confirmed cases and deaths in various regions of the globe. And you can see China has like 77,000 confirmed cases and 2,663 deaths. And then you can see the United States way down here at the bottom at 53 confirmed cases and then 0 deaths. And wow, what a difference a couple months makes, right? But anyway, the point of this graph, this appeared in the New York Times, was to draw our attention to the raw data so we can look at the figures for ourselves, right? And that's why you want to use a table, right? And the final thing, the final point I want to make, if you're wondering whether 2π or not 2π, the answer is you usually shouldn't pi, right? Unless you're making an edible one. Edible pies are fine. Visual graph pies, not so good, right? And to make it clear why this is, why visual data people really hate pie graphs, I'm going to show you this example here. So this is a real simple example that I took offline, right? This is just somebody's expenses, and they got food, transportation, bills, and other, right? So you can see a pie graph here. The pie graph gets the main point across, right? Which is that bills overwhelm all the other elements of the person's budget, right? So they're a little over 50%, right? And so that gets that sort of main argument the person's trying to make across. But the problem with it, right, is that it makes the individual differences between the other parts of the pie really extremely unclear, right? So it's really difficult to see at a glance, is 425, is that pie bigger than that pie? Without the numbers, in fact, it would be impossible, right? And as one person, I think Alberto Cairo, who is a data visualization expert, says, if you're including the numbers, right, then in a lot of the exact numbers, a lot of ways you're failing in your visualization purpose, right? So here's a more effective example, right? So here is a bar graph, right? And so you can see here at a real quick glance, not only can you see the overwhelming effect of bills, right, but you can also see the differences between the other items too, right? So if it was important for people to be able to figure that out at a glance, they could do that as well, right? So for the most part, I think you should avoid pie graphs. The only thing I think pie graphs are really useful for is when you're comparing two items. In that case, a pie graph might be useful, but in most other cases, other methods like a bar graph are going to be more effective, right? So anyway, keep these things in mind as you're putting together your data visualizations for your paper and you're analyzing your data. I'm going to put together one really short video where I look at some tools on Excel that you can use to analyze your data more effectively. And hopefully you have fun looking through your survey results. If you have any questions about it, just let me know.